All right, now we're ready for type 2 naming, and these always involve either a transition metal or a metal that can take multiple charges. So there are two metals that are not transition metals that I'd like you to know can take multiple charges. So these poor metals, tin and lead, they're actually called poor metals, can take either a +2 or a +4 charge. So the Roman numeral, which specifies the charge of that metal ion, is necessary in this naming. So you will always need a Roman numeral in the name of these ions, in these compounds, and that gives the charge, not the number, but the charge of the metal ion. So it would be a problem if these two compounds, CuO and Cu2O, had the same name. We can't just call them each copper oxide, they both exist. But what's different is the charge on each. So the reason why you have a different number of coppers is to get a balanced charge of neutral or zero. You have to have different numbers. So the copper ion has a different charge in each of these. And we're actually going to do a reverse crisscross in order to figure that out. So if we have a 1 here and a 1 here, that's one way of looking at it. But the whole key to this is knowing the charge of your anion. If you know the charge of your anion, then you're good. So for copper oxide, CuO, this copper oxide, we don't know the charge on Cu, but we know there's one of them. We know the charge on oxide is always -2 because, as I should review here, ions that are in column 7, group 7, take a -1 charge. They have 7 valence electrons, so they take 1 extra. In group 6, they take 2 electrons to take a -2 charge. And in group 5, they typically take 3 electrons to get a -3. So we know oxygen is going to take a -2 charge in most ionic compounds. So if oxygen has a -2 and there's one of them, then copper must have a +2 in order to balance out. So for that reason, we name this copper Roman numeral 2 oxide. So again, it's the charge, not the number of coppers. For this one, Cu2O, we know oxygen has a -2 charge. And we have 2 coppers. So the only way for those coppers to balance out is if each one has a +1. So copper +1 and copper +1. With those 2 copper ions, that balances out the -2 charge for oxygen. So this one, if we give a Roman numeral for the charge, it's going to be copper Roman numeral 1 oxide, copper 1 oxide. So going from the formula to the name is tougher. It's much easier to go from the name to the formula. So for lead 4 nitrate, we know that Pb, lead, has to have a 4+ charge. Nitrate, we remember from our polyatomic ions, has a -1 charge. So in order to balance this out, we're going to need 4 nitrate ions. That's a lot to write, but I like illustrating that there's 4 of them. The way we show that in a formula is Pb, parentheses, NO3, 4. So that balances the 4+ charges for lead. Remember, lead's not a transition metal, but it still goes with the Roman numerals. And there's 4 nitrates. Each one has a -1 charge, balances out to 0. For any of these, if you want to pause and try them before I do it, that's not a bad way to go. So if you want to try tin 2 chlorite right now, you can pause and try it. And then also for CrOH and CrS3, that works as well. I am going to add one last one. Tin 2 chlorite. So Sn is tin, and we're told it has a 2+ charge. Chlorite is ClO2-, so we're going to need 2 of those. So tin 2 chlorite is SnClO2, parentheses 2. Parentheses are very important for polyatomic ions. Otherwise, it would look like NO34 or ClO22. So those parentheses are very important. For E and F, and then I'll add G. You can pause if you want. So chromium and hydroxide. Do we know the charge of hydroxide? Remember, OH is a polyatomic ion, so we name it that way. And OH has a -1 charge. So OH with a -1 charge means that the single chromium has to have a +1 charge. And the name for this, because chromium has a +1 charge, is chromium 1 hydroxide. So remember, these are only for transition metals and metals that can take multiple charges. If it's in group 1, group 2, group 3, or if it's silver or zinc. So any of these guys don't apply to this. So these guys all take their own fixed charges, so they would be type 1. These only go for the transition metals and then those 2 extra metals I specified. CrS3, give that one a try. Sulfur has a -2 charge. There's 3 of them. So that means chromium must have a +6 charge, or 6+. So this one ends up being chromium 6 sulfide. I'm going to squeeze it in here. We use Roman numeral. Okay, I'm going to throw in one more here. So G is AlF3. Pause, give it a try. Okay, so the trick for this one is we don't need a Roman numeral. Aluminum is in group 3 and always takes a +3 charge, so this one is just aluminum fluoride. Some students call it aluminum 3 fluoride, that's incorrect, or aluminum trifluoride, which we'll learn later for a different type. It's not correct. So this one is just aluminum fluoride. Tricky.